All right, we've covered this several times in class, but let's take one more look at that PMT function and how that works in loans. And then we're going to learn a new function that can also help us with determining how long a loan should be. So maybe we're buying a car, who knows, but we've got our purchase price, trade-in, down payment, loan amount. So let's go through that real quick. Let's say we've got a purchase price of $40,000 and we have a vehicle that we can trade in for $4,000. And we decide that we're going to put $5,000 down. And so what that should do is make the purchase price equal to, or excuse me, the loan amount should be equal to the purchase price minus the trade-in value minus the down payment. And that gives us a loan amount, the money that we need to borrow from the bank, of $31,000. Now, let's say our interest rate that we've been able to secure on a car loan is 3.2%, just as a reminder. That is actually 0.032 in decimal format. Now, if we wanted to, we could go and highlight that cell and format it as a percentage, and then it will show as 3%, or we could go ahead and bump out that decimal place and see the full 3.2%. Now, the terms in months, let's say this is going to be a 4-year loan. So we're going to do 48 months. And now what we need to do is calculate what will the payment be on the loan each month so that at the end of those 48 months, the loan gets down to 0 when we make equal payments every month. So we're going to go ahead and hop into the PMT function. And you see right away our first parameter is rate. Now remember, this is an annual interest rate and we are making monthly payments. So we need to convert that to our monthly rate, which would be done by simply dividing by 12, as there's 12 months in a year. All right, NPER, number of payment periods. We would like to make 48 payments. So we're going to select that cell. And then present value, how much do we hope to borrow at the beginning of the loan? And that would be that $31,000 up here in B4. Future value, we're going to assume 0. And the type is whether or not the loan payments are made at the beginning or the end of the payment period. And we're also going to go with the default on that, so we don't have to choose those parameters, because remember, parameters that have square brackets around them are optional. All right, so it looks like we need to make $688.91 payments per month to pay off this loan in 4 years at 3.2% interest. So that should be review at this point. But let's say we're sitting with a client or a customer and they say, well, I can't afford that much. And you say, well, what could you afford? And they say, well, I think I can do $500 a month. All right. So let's look at a different function called, and I'm just going to write it in this cell right here, NPER. And what this function does is it takes a rate, just like the PMT function. We need to convert that to a monthly rate. And just like the monthly payment here that was calculated by PMT as a negative number, we need to tell it, remember, our client told us I can pay $500 a month. So we're going to say negative $500 to keep it consistent with that negative number that we got from the payment function. And the present value of the loan is the same, $31,000. And again, we hope that the future value will be 0. So we can take that as the default and we don't have to worry about beginning or end of payment period. So when I close the parenthesis here and hit enter, what NPER tells me is that it will take me 67 payments, almost 68, to pay off this loan at a payment of $500. And so I can take that number and perhaps divide it by 12, which would be a little over 5.5 years. And so what that gives us the option to do is to say, well, you know, how much can you pay? I can pay this much. Well, then we're going to have to do a loan of a certain duration. So if we were going to make this spreadsheet a little more useful, I could maybe drag this calculation down here, and this would be the loan term. We'll do this just in these smaller font. And then if we say payment amount, payments I can afford, and let's say it's even lower, it's $450. I'm going to highlight that and just make it into currency. And then I'm going to go adjust my formula right here to refer to that cell. So instead of hard coding in -$500, I'm going to actually tell it, hey, look at B11. And if I hit enter, I should have made that a negative number, that 450. So 6.3, and I could even get rid of the divided by 12 if I wanted to, and just say, really, you know, how many months do I have to pay on this loan at $450? At this point, we're at 76 months. And so I could maybe, you know, say, well, maybe I could do 475. And if you can't tell, you know, now we're at about just under 6 years. So maybe that's the way we want to go instead of that 48 months. So NPER takes everything except the number of payment periods. And it even takes a payment, whereas the payment function obviously is calculating the payment, and you tell it how many payment periods you would like. So both useful functions, and hopefully they can do well to help you on your exam.